Hello, everyone. Welcome to our webinar, Building a Data-Centric Lab, hosted by SciNote. Thank you for joining us today, and we're happy that you're here. So we're going to get started. So I would like to start by first introducing all the speakers here. From the left to right, we have Klemen Zupancic. Klemen, do you want to wave a little bit? Great. Klemen is the founder and CEO of SciNote. SciNote is, let me get to my quote. SciNote is the lab digitalization company whose main product, SciNote Electronic Lab Notebook, is the chosen solution by researchers as FDA, NIH, and the European Commission, and 90,000 plus researchers over 100 countries. And then you have me. I'm here. I'm your moderator today. So I'm Teresa Liao. I am the content marketing specialist. So you will see me making an introduction and hosting the Q&A session later on. And then we have Alan Millar. Alan, do you want to wait a little bit? Alan is a VP of Tetra Partner Network. TetraScience is the R&D data cloud company with a mission to transform life sciences R&D, accelerate discovery, and improve and extend human life. The Tetra R&D Cloud is the world's first and only open R&D data cloud. And next we have Matthias Doering. Matthias, do you want to? Who is the development team lead, and he is from BISC Global, which is a bioinformatics, biostatistics, machine learning, and AI consulting company. Their expertise in data analysis, pipeline development, and automation, data integration, cloud solutions, and biology allow them to provide bioinformatics services of the highest standard. So we have all the speakers here, and I'm going to go over quickly the agenda for today. We are currently in introduction, and every speaker will have 10 minutes to talk about their, the topic that they're an expertise in. So we'll go through all three presentations, and then we're going to go into a discussion on how to build a data-centric lab. And then there will be a Q&A session where you can ask all the questions to the speaker. We'll leave the questions to the very end. So you can, however, if something pops up, make sure to leave the question in the Q&A box, and we will come back to the Q&A box. You can see that in your Zoom interface. We will come back to that at the end when we get to the Q&A session. Okay. So we're going to start by first doing a poll. You will see the poll popping up in Zoom right now. Which stage of the process of building a data-centric lab are you currently at? We'll give everyone a few minutes to vote on this. Are you at the stage where you are just thinking about it, or you're here because you literally have no idea what it is, or you're at a stage where you really actually have a data-centric lab and you're hoping to see what the future holds, or if there are other opportunities to explore down the road. So we're gonna give maybe 30 more seconds for people to fill out this poll. And this will give us a little bit more information about all the attendees today, and it can help us kind of adjust our materials a little bit. And it's also, poll is always fun, so. Okay. I hope that's enough time. So can we close the poll now and see the results? Perfect. Perfect. So, okay, that's great to know. So in the poll results, just for our video audience in the future, most of people, 50% of the people say, I'm not sure what a data-centric lab is. So I would like to learn more. So so that's about half the people. And then 30% of people are considering implementing. And then there are another 13 and 6% of people who are either in the process or who have already had a data-centric lab, but hoping to explore other opportunities. Perfect. So we are going to go into our first presentation. And I think I'm going to stop screen sharing. Let me just make sure that, perfect. I'm going to stop screen sharing. Okay, and our first topic, for our first topic, we have Alan. Alan from TetraScience. You are, it's all yours.
That's great. Thank you very much. Can you confirm you can see my slides, okay?
Yes, we can see your slide.
Great.
Excellent.
Well, good morning, good afternoon, folks. It's great to be here. By way of a brief introduction to myself, Alan Millar. I've been at TetraScience for about 12 months now, and my role at Tetra, I think, is an exciting and interesting one. But put simply, my job is to listen very carefully to the needs of our customers as they try and maximize the value of their scientific data. And my particular role is to, based off those prioritized needs of customers, go out into the life science industry and build truly value-add relationships with the major vendors. Those relationships are very squarely focused on providing added value to the customer and also to the vendor. And of course, SciNote is a great example of a really profitable and trusted partnership that Tetra has with a leading ELM vendor. So that's me, but let me just say a few words about TetraScience as a company. I think, as was said in the introduction, we're really very focused on our mission, which is to accelerate discovery and improve human life. And to put simply, the role that we play in that is to enable our customers, and our customers are biotech and pharmaceutical industries, to truly maximize the value of their scientific data. And the theme that I'll develop during this course is, really it's about building the foundation to do that. And for TetraScience, that means deploying a cloud-based platform which enables users to centralize all of their scientific data and to harmonize that data to a vendor agnostic standard data format, which then makes that data, we say, liquid and actionable or available for subsequent use cases. And there are a variety of use cases that we'll discuss throughout this webinar today, but they could be, improving efficiencies in the laboratory or ultimately striving to produce better scientific outcomes. In terms of Tetra itself, we're a growth stage venture-backed company. We're growing rapidly. We're engaged with many of the world's leading pharmaceutical and biotech companies. As it stands today, we're over 200 folks. The company itself actually started with a IoT or Internet of Things approach to lab monitoring, which was very well received by our customer set. But as is often the case, the feedback we got from our customers was, that's a really interesting and useful use case, but we think there's a bigger calling. And the calling is to extend your purview to all scientific data. And that's exclusively our focus today, to the extent that we actually divested that lab monitoring IoT part of the business at the back end of the year. But the company itself is a fairly equal mix these days of folks with extensive tech, cloud backgrounds, and life science background. And we think it's critical to do both. We need to fully understand the potential of cloud-based technologies, but we have to talk the language of our customers, which is clearly life science. But let's really start, as we should, by putting customers at the center of this. And what we heard and continue to hear repeatedly is that there's a big challenge that biotech and pharmaceutical industries face in maximizing the value of their data. And put simply, as you can see on the screen, insufficient access. It's often the case that high quality data has been processed, the primary processing has taken place in world-class application-specific, vendor-specific software packages. But it's not unusual for those software packages to be on-prem, and therefore getting the data from them for additional analysis can often be hard or difficult to do. Our customers tell us there's way too much tedious and error-prone manual transcription in their data workflows. And there's two big problems with that, or at least two big problems with that. It introduces the opportunity for errors, and it also consumes a great deal of time in which scientists should be thinking about their science and not wrangling with the data. And all that leads to the inability to truly be able to maximize the value of the data, the inability to analyze it. Succinctly put, these are the challenges that TetraScience is completely focused on helping our customers overcome. So the way we think about the current state is, as I said, and as we all know, there's a multitude of analytical testing methodologies in the lab. There's a multitude of applications that consume the data. And the visually busy slide on the screen is meant to be busy visually to represent that. So we have sources that produce data on the left and targets that consume data on the right. And it's typically the case today that the connections or the integrations between them can be brittle and point-to-point, one-off, often custom-produced solutions, which don't have the flexibility to grow with the needs of lab and often don't provide the workflow automation that's required to ultimately be able to fully maximize the value of that scientific data. The core theme here is that if we do want to maximize the value of that scientific data, and if we want to go on and do things such as AI and ML or even data science, that's only possible if you have the foundation of your scientific data being both available and in the correct format, availability to be used for that purpose. So we know that ultimately we want data to be fair, findable, accessible, interoperable, and reusable. But that's really based on a foundation of integrations, we think, the ability to connect to those assets in the laboratory that produce the scientific data, which makes it, of course, findable and accessible. And also that data being engineered into a format which is compatible with the end use cases. And again, go back to, we have so many different analytical testing methodologies in the lab. Typically, they all come with their own vendor-specific data format. So what TetraScience is striving to do is to be able to harmonize that data into a vendor-agnostic standardized data format, such that you can then move up the pyramid and really reap the full vantage and value of that scientific data. But the key point of this slide is, before we can conceive of doing the advanced analytics and AI ML, first we have to build that foundation of data integration and data science. So the way in which Tetra helps its customers do that is to provide a cloud-based platform, which is represented in the middle of the screen here. And quite simply, we focus on integrating, as I said previously, into those assets in the laboratory that produce the data. And we typically classify those as instrument control software. So think maybe Waters Impowers CDS, Thermo Fisher, Agilent, so on and so forth. Typically, we will also encounter lab informatics products such as ELNs or LIMS. But there are really a variety of sources, a wide variety of sources where that data comes from. So really what we try to do with the Tetra Data Cloud is to centralize that data. So we integrate to the data sources, and we do that via productionized integrations that can be reused rather than one-offs. Now, those integrations can be via an IoT device for simple pieces of instrument that are not connected to the internet. It can be by monitoring file locations and grabbing files when made available, or it can be through APIs for more sophisticated integrations. Once we take that data to the data cloud, it's centralized. We can then apply metadata, we can enrich that data, we can validate and verify that data, and then we undergo that step of harmonizing it to a standardized data format. And that is a JSON vendor agnostic data format, which was influenced by Allotrope Foundation, for example, and engagement and interaction with all the vendors in the space. That means that data is then available to be moved to those applications that consume data, whether they be advanced analytics or other laboratory informatics types products. It's also really important to note that we fully believe there is no one vendor on the planet that can do all this alone. And so you can see on the bottom there, we talk about the Tetra Partner Network. And this really is the ecosystem of vendors that we think have to collaborate to come together to get customers to their desired endpoint. So to talk a little bit more about that, we spend a lot of time engaging with vendors, putting the customer need at center, but engaging with vendors and saying, look, we have a common customer whose desire is to automate a workflow or produce some advanced analytics. And it's really through partnership between TetraScience and the vendor that we're able to provide that functionality or capability to the end user. And again, we think about this ecosystem in terms of informatics products, and there's a huge pull both from customers and vendors to collaborate in the informatics space, but also, of course, instruments, data applications, and system integrators, so on and so forth. But it's a really key point that the data platform, the data cloud platform in the middle, has to work hand in hand with this collaborative ecosystem of vendors around it to truly deliver the value to customers. We know that this resonates with customers. We've asked them, of course, and we interact and engage them all the time, but I'm just going to put some sort of high-level figures on the screen from a survey that we've undertaken, and you'll be able to see the full results of this shortly on the TetraScience webpage. But maybe unsurprisingly, when asked, the biotech and pharmaceutical industry say, yes, if we had the capability to truly maximize the value of our scientific data, if it was available for us, searchable, findable, liquid, and available for subsequent use cases, we think we could go much faster, 64% faster. We think we could dramatically improve risk reduction. So there's a huge input or value add there. And we also think there's the opportunity to reduce costs through time saving. So maybe unsurprisingly, the industry is saying to us, yes, we can do more with our scientific data. And if we could do more, we think there are substantial values to be extracted. I'll move quite quickly through the next few slides, but I just wanted to show some brief sort of application use cases, and some of the subsequent speakers will talk about what we can do with the data. But this might be a very simplistic but representative use case that one of our customers would undertake. In this situation, it's a protein purification workflow run on an actor system. That data is centralized into the Tetra platform, harmonized, and it undergoes the processes that we spoke about. That data is then readily available to be communicated into and out of an ELN or a LIMS system, or to be used for more advanced analytics. But importantly, what that means is we've given the opportunity to reduce errors associated with manual transcription. We've demonstrable time savings for the scientists. And of course, we offer the opportunity to improve efficiencies and better scientific outcomes, because you can facilitate reporting and look at things like instrument usage, method performance, trending, consumable usage, so on and so forth. I'll move quickly through this one as well, but this screen just shows the output of some applications which are actually developed by a partner of ours, Waters Corporation. So in this instance, we've extracted LC data from Empower CDS, chromatography data system. And then we've been able to, working with Waters, offer analytic dashboards. In this instance, on the left, looking at things which may give you insight into compliant, or more specifically, non-compliant issues. So here we've been able to say, okay, one particular user is manually processing or reprocessing data more than other users. Why is that the case? Does that person require more training? Is there a particular issue with their instruments, so on and so forth? And of course, these can be incredibly impactful insights, because they can ultimately lead to observations of non-compliance, so on and so forth. And on the right there, very briefly, you're able to look at instrument usage and map that to a laboratory, so you can start to get some insights as to why some instruments are over or underutilized compared to others. So that sort of brings me to the end of my brief presentation, and hopefully I've shown you that we think there's a real need in the biotech and pharmaceutical industry to maximize the value of the scientific data. We think the role we play there is in the preparation, the integration, the engineering of the data to make it both liquid and actionable. And we really think it needs a new way of thinking to achieve that. And that really is, this harmonized data available in the cloud. We think this needs a rethinking of the vendor ecosystem to a more open, vendor agnostic situation. It needs a purpose-built cloud-based platform to truly benefit from all the cloud-based capabilities that we know. So I'll leave that one on the screen, but that concludes my part of the presentation. Thank you very much for your attention. I'll now stop sharing my screen and hand over.
Perfect. Thank you so much, Alan. So we had a great overview about the preparation of data, having your data ready. What about the analysis part? And that's the next session, the next presentation. Matthias is going to go ahead and share his insight for the data analysis. And also a reminder, if you have any questions during the presentation, please make sure to enter that into the Q&A box. We will be coming back to those questions at the end of the presentation.
Right, thanks you, Teresa. So very happy to be here at this webinar from SciNote, and I hope to share some insights with you on the data analysis part and some of the best practices that we're using at BISC to do that. Before I start off with the main content, just want to give a short intro of myself as well, same as Alan. So started a PhD in 2014 in bioinformatics at the Max Planck Institute for Informatics. They worked a lot with machine learning, focusing on viral infectious diseases, also on primer design in the immunological context. And one learning there as well was for me that I really like to, develop solutions as well for, hands-on problems and to provide solutions for customers, which is always not possible in the academic space. So next on, I moved to Deutsche Bahn in 2019 as an application architect, working as well a lot in the ML sphere, doing model serving for machine learning, reinforcement learning, and also a lot of DevOps engineering, getting first experiences working with cloud systems. And then in 2021, going back to bioinformatics, working with BISC. Currently, I'm development team lead there, and there I'm mainly concerned with developing new bioinformatics solutions, new products. Main interests there are in cloud solutions and immunoinformatics, and one of the focus in the company as well, of course, data analytics and developing robust bioinformatics workflows to get data analyzed in a quick and robust fashion. So short intro about the company. So this was founded in 2017. As a founder, saw the need that people are generating a lot of data, and there's a lot of instruments to do that. But the real value nowadays lies in the data analysis and getting the insights from the data. And as you can see, since then the company expanded a lot, starting in Ghent in Belgium, then moving on to Boston, USA, Switzerland, Basel, USA, San Francisco. 2021, we also opened offices in Amsterdam, and now this year as well in North Carolina in Durham. So what is the company about? So BISC stands for Bioinformatics and Statistics Consulting. So that's the main thing that we're doing. So we have basically 3 problem domains. So one thing where we help our customers in the life sciences with is basically our, let's say, standard consulting projects, which means customers have data. We have the algorithms, we have the knowledge to analyze the data, visualize the data, interpret the data. So that can help, for example, companies to see if their biological use case actually holds when they're still in the startup phase, and then to see if they can continue that, for example, looking at a specific target. We also build custom software tools. So this can be something like a dashboard, can be a tool to run a machine learning model, anything relating to biological data. And the final thing that we do is to work on automation solutions. So that basically means we build cloud solutions where we do automated analysis, where we build data lakes for data storage and data interpretation. As I said, nowadays really data is being generated in a much greater extent than in the past. So this is just a showcase where you can see that the data deluge is real, mainly taking off from 2000 for biological data. So this is the amount in blue for sequences and GenBank. And as you can see at the point where the human genome was sequenced in 2021, this is really starting to take off enormously. And I think the trend is going to continue. So what we really need is people that look at the data, do the analysis, which sometimes, of course, is a manual step, but also for automated systems that perform these tasks to deal with the huge amount of data. And when we look at data analysis, of course, one crucial consideration is reproducibility, meaning that, basically if you do the same analysis twice on the same data, it should give the same result. Unfortunately, this is not always true, also in the scientific field. So here on the left, you can see a chart where you can see basically the confidence of researchers in respective fields such as biology or medicine. And at the top of this histogram, basically 100% indicates it's 100% link that everything is reproducible. And that's not actually the case. So the median is more somewhere around 50%, 60% of feeling and reproducibility, which showcases that there's really a problem in scientific studies as well. And that also relates to the quality of the used data analytics methods and approaches in general. So one example where we can look into that in more detail is if we look at biological data, when you do studies on genes, for example. A lot of researchers, they're still using Excel for data analytics to collect their data. As we have seen in the past, it's not an optimal tool. For example, there are some genes like the MARCH1 gene, which are actually interpreted by Office as a date rather than a gene symbol, which led actually to some falsifications of big scientific studies, with in fact about 1/5 of published studies being affected by that. Basically, which shows there's some basic things like selecting the right tools for working with data is crucial to get good results actually. So one of the main takeaways I want to make is that data analytics is not just data analytics, but it's basically a whole ecosphere of different fields and different people, different systems interacting. So here is just a showcase of what you can have as a typical layout. So for example, of course, you need someone, a person that's doing basically hands-on data analytics, right? And the standard thing is that you then have some manual presentations, some business insights that are attained by the stakeholders, and action is taken ideally based on this analytics. But that's not everything, right? Because you want to get some more value out of that. So it's basically necessary to also have software engineering mindset. You have some applications that you want to develop where you want to put the insights from the data analytics into there to create customer value. And then you also want to ensure the quality of the software. You want to use version control, you want to use the ICD, you want to check the quality of the software. So that's the one additional aspect that I think is very important, to have these best practices there. And then also you want to look at basically this data engineering context, which was already mentioned before by Alan, which I think is also crucial, of course, because you need to have the data, of course, present for data analytics to happen. You need to have it annotated, processed, structured. And also you want to gain further insights through the data. So when you have your, let's say, nice data lake, right? Of course, what you want to do is you want to run some machine learning and automated data analytics on that to gain even more value from the data you collected over the years. So I think it's really crucial that all of these things are connected: data engineering, data analytics, software engineering, to get the most out of the data. So more in practical terms, what I believe are really basically the fundamentals of getting good results with data analytics. I think, of course, there's a lot of very complex high-tech tools that you can use, but I also believe very important to have proper foundations. So from my experience, these can actually be lacking, especially in the research domain. One thing I definitely would always recommend is Git, meaning version control systems to track the code. So that allows you to try out new things, if necessary, revert, collaborate, do code reviews. So really an essential to working with code in general. Then if you want to work on projects, structure them, monitor them, collaborate, I would definitely work with Jira to do that, because otherwise it will be very hard to keep track of what is going on and deliver projects on time. Another thing that's very important to me is having the software quality, and I think nowadays that can really be well enforced with CI/CD systems, meaning continuous integration and continuous delivery systems, so that the code is automatically tested and also automatically deployed to the servers where it's running. So that's more relating to making data analytics production ready. Then we have, of course, Docker and containerization tools in general, meaning tools where you can basically put all your dependencies in a container to ensure that your software is actually reproducible. Something which is always nice. A lot of people use environments such as Conda for that. That's also an alternative. But yeah, if requirements aren't tracked, there will be a big problem when you want to bring your code into production. Finally, to really go and scale things up, you should definitely keep workflow management systems on your radar, such as Nextflow, to connect different steps in a pipeline of analysis steps, and then also to consider putting that on cloud systems such as AWS to really scale up to the big data. So now you may ask, okay, what is the BISC doing in this domain to write some solutions for providing these nice data analytics solutions to make them more robust, more efficient? And what we developed is OP Square, which is short for online pipeline platform. And the idea of this platform is to provide easy to use bioinformatics analytics pipelines to users. We're currently offering 4 different pipelines, so bulk transcriptomics, single-cell transcriptomics, immunorepertoire analysis, and variant calling for standard DNA. And for all of them, you can just upload your samples. Then they're processed on the cloud, and then you get a nice short report, as you see on the right, about the quality of the data. And of course, also on the downstream processing results, which can then use to take further action based on the data. And I think that's a really nice solution that a lot of people can use, because at the moment there's, of course, lots of different standards out there. And on OP Square, we really make sure that we're using the best available tools, and also making sure that you get the results in the quickest possible manner. In general, as a company, we are active in a wide variety of domains. So basically any biological domain, from genomics to metagenomics, epigenomics, and immunology. And we are focusing on machine learning tools. We're also doing cloud solutions, working on data lakes and databases as well. So any of these areas we can supply custom consulting services. And we're working also with quite diverse customers, mainly focusing on companies in the pharmaceutical and biotech industry, meaning, of course, also big companies such as BASF, and also companies that are more focused on individual use cases like absolute antibodies. We're trying to develop new biologics as treatment, but also tech companies such as TechBio, which try to create value from data and make workflows accessible to end users that want to use biological data processing tools. So with that, I'm concluding my presentation. Thanks to you for your attention. And if you have any questions, then please feel free to ask me. And if you're interested in working with us, then don't hesitate to contact our CEO and founder, Martin Prespening. Thank you.
Perfect. Thank you so much, Matthias. So we came from preparing the data, and we have gone to analyzing the data. Now we're going to talk more a bit about, on the ground in the lab, what does, a data-centric lab, what does lab management looks like? Sorry, data management looks like in the lab. And Klemen, go ahead. It's all yours.
Hello, and welcome from my side. Teresa, can you just confirm you see the screen? All right. Okay, so thank you to Alan and Matthias to join today's webinar and talk about these things. So a little bit about, just as an introduction from my side. Apart from being the co-founder and CEO of SciNote, I spent part of my career in the lab, so I felt the pains firsthand, let's say, and I became really a strong activist for open science, data sharing. A lot of things what Alan was saying kind of resonate very close to my heart, I would say. And this is also the reason why we're doing this webinar, why we have the partnerships. And yeah, I think more talks like this, more of use cases like this will just make more people work, you know, to basically get more from science. So just a little bit about SciNote, and we'll get to that in a second. So SciNote is an electronic lab notebook and an inventory management system. It's used by scientists all around the world, both from academia and industry. We have a couple of big names, R&D departments of a couple of big governmental companies as well, both in US and in Europe. And we support labs that grow, that start kind of like the three main streams. So new labs, startups, labs that will need compliance in the near future, like they're doing maybe some clinical trial, to more mature labs that need all sorts of regulatory compliance, like namely with 24 Part 11, from the FDA, 21 CFR Part 11, various GXP compliances, and so on. But kind of where I started to go, and before, like I think really what describes it well is this quote from Herbert Spencer. He's also he created the quote "survival of the fittest." So he knows his way with words, I would say. So what he said is SciNote is organized knowledge. And when I said that I felt the pains at the bench, this is what I was referring to. Like we were creating so much knowledge with the experiments, and as Matthias will show, it's a huge pieces of information, but it wasn't connected together. It wasn't organized well. So how much science were we really creating with the knowledge, with the data that we generated with our experiments? And kind of another quote that I wanted here to take is really, the one could argue that the majority of the value that you generate as a scientist is not per se by your publications and your discoveries, but really as the building block, as the foundation for what others were able to derive in the future from your work. And this is, data is here at the core because it's part, or it's the actual fundament in this argument. So really, scientists are not just doing the research for what their questions, what their immediate questions are, but they're doing it for everybody, for the whole community. So this is, and this is pretty much why fair data is important for us, why collecting the data in a digital manner on the cloud is important to us, and we share many of the basically values and let's say strategy and logic here with TetraScience, as was described by Alan. So why should somebody, if you're a scientist, why are, apart from, contributions to the future of society, why should you, are there maybe more practical ways or reasons why you should care about proper data management? Well, first of all, whoever is either your regulatory body or your funding agency, they'll definitely want more. We see the trend, so they'll want more data management from your side, particularly in the digital sense. So we see a huge trend with funding agencies, especially requiring scientists having data stored in certain ways. We see a huge pressure in industry, starting from the big pharma, to extract maximum from the data, as Alan was mentioning, as basically what Matthias's company is doing. So because we want to get to big data, AI, have huge data pools, and maximize the potential of that data by extracting those subtle patterns that can only be found if the data is working together in a organized, fair way. So how is your data managed here? I wanted maybe kind of like the same point that Alan was making, but from maybe a different perspective. Often when we talk to our customers, there are these expectations, and we even saw this internally when we talked. There is this expectation that ultimately there will be one system that you'll click one icon on your laptop and you'll see everything on one dashboard. You'll just use one software for everything. So this is kind of like maybe an unspoken expectation, but something that people believe that eventually, as they go through the digitalization process, somehow the tools will get less and less. The tools will get consolidated, which is, I think everybody can confirm this or agree with me that at least in our personal lives, there is a digital explosion of tools. So we're definitely going to get more tools, not less. So that's maybe something to keep in mind, and having the realistic expectations. So data will not just be stored in one place. There will be some data that is transferred between places. There will be some data that remains at the original place. And that's okay. That's totally fine. All that you need to do to ensure the data is fair and the data is reusable and connected is that data basically has as Alan said, the data is fluid. The data is in the right format, and it's stored in a way that it can be easily accessible by other software tools and people. And we'll get to a bit more details on how we think about this. But it's basically also how you have these different types of software, one that kind of generates the data and wants to communicate it outwards, and then you have the integrator software that connects the data, pushes the data to other connectors, and we'll get to more details of that. So connecting the data dots. So this is maybe kind of stemming from that integration, but there will be this one giant system of tools, and all the data will be seamlessly integrated, stored in one huge database. But in reality, there is so much data being produced nowadays with so many different devices, software tools, people in the organizations, let alone, let's say, the scientific community, that it's, very quickly you get you have more potential connections than there are, particles in the universe. So pretty much this dream that everything is connected with everything directly is unrealistic. And it's logical, but sometimes people have these unspoken expectations when they're starting with digital software, let's say with digitalization processes, and how we talk about this on this webinar about the data-centric approach. So what we believe is that it's better to have dedicated endpoint software tools and then centralized software tools. And this can be, how this is constructed can be very it can be built in a very custom and complex way. So basically what an example here is like we see a big centralizing, let's say, node here, software that connects data from multiple tools, and then being an entry point for even bigger software that is maybe company-wide. And there doesn't even have to be one big software that kind of rules them all. But even if the connectors are connected with each other, you have much lower number of connections that you have to make, and everything talks to everything else by sending and receiving only the information that is needed in the next stage of data. So what we really think is where we want to be is we want to build on this foundation and basically be able to kind of put the open science and I really like the term, Alan, liquid data, like to enable this liquidity in the data. So the way we see and let's say features or main kind of priorities for SciNote that we feel also other software and other tools in this ecosystem should have is basically to be really open and transparent, so not necessarily open source, although we at SciNote chose that route. But open in what kind of data formats are we using, what kind of databases are we using, how is this data connected, so that people who end up using the data understand the logic and structure behind it. How so having the open API, the API connectivity enabled is at the heart of this. Basically enabling all this connectivity and but all this connectivity doesn't happen on its own. In the end, it's really companies that have high incentives to be connected, but still need to sit down and do the hard work of actually doing the integrations, doing the connections, not only so that data can flow, but the data can flow in a way that really benefits whoever is kind of subscribing to that data. So on that note, we do have quite a large number of customers. So we see this customer space not customers, partners. We see this partner space very similarly as TetraScience, and we feel we need to connect. We need to focus on what we do best, and then really follow the use cases with the customers and see what they're using and connecting the data that way. One kind of like the last angle that I want to say here is that everything that we talked about today, all three talks talk about, and we've seen the poll, right? A lot of people are kind of like on the verge of this process. It's a transition, and a transition is stressful. It takes time. It takes patience. Some people are more easily convinced to transition and change their habits. Some people have more difficulties with this. So we need to have a big amount of patience and understanding, and really approach everybody in a way that is helping them not only understand the tools that they're using better, but also understand why they need to use them, and basically make them part of the solution by including them in the process and so on. And this is, I think, where at SciNote we are really strong, and we approach our customers very directly with our training materials and processes to get them on board with it, to make them successful. And we found this to be really crucial to our success. So if you feel like SciNote could be a good fit for your data ecosystem, or if you're just unsure, definitely visit our webpage. You can get free trial, but also we have everybody that you'll talk to has seen many use cases. We have people that were at the bench that you'll talk to, and they'll be able to give you at least advice and guidance in what should be the best next steps for you. Every lab is different. Every lab generates different data for different purposes. So it's not a one size fits all. And as Alan said it, that there's no one software that will, you just get that and everything that works, like maybe what you expect from Apple. Science is too complex, and we are too early on to figure out what there are so many things to connect that for the foreseeable future, you'll need to find what fits best for you. Okay, so that's it from our side. I hope it made some sense, and happy to answer any questions.
Thank you, Klemen. So with that, I'm going to move into the next stage, which is our discussion. And oops, let me see, make sure that I do this. Perfect. So the discussion point, and because we're running a little bit high, I would like to sort of combine the discussion with a little bit of some questions that we've seen a little bit. And so basically, our focus is how to build a data-centric lab. What do the presenters here think is the most critical factor when it comes to building a data-centric lab? And based on the presentation, I can think of a few, but I would like to hear from the presenters, and perhaps we can start with Alan to go with that.
Yeah, I think this is a topic we could spend an hour on
Yes.
in of itself, to be honest, but maybe some observations that I've seen in engagements with customers generally around this, data centricity or digital transformation. At some point it comes down to being able to speak to a demonstrable return on investment. So I think that is at least one critical element in terms of gaining alignment and buy-in that's required to undertake this type of activity. So, one piece of advice would be have some very concrete and demonstrable return on investments that you think can be achieved. And really the right people have to be bought into those. Now, whether those return on investments are, we think we will improve efficiency by X% by saving this number of hours per day of key scientists, that could be one. It could be, we think the return on investment is going to be minimizing non-compliance issues, which of course have a huge monetary value associated with them if you fall foul of them. It could be, we're going to use our laboratory instrumentation more effectively and efficiently. So have a clear set of ROIs that you can associate to this journey. And then I think there needs to be a realistic path from the current state to the desired future state. So you have, very clear return on investment so you can get alignment, but then a very well articulated path of, and this is how we're going to undertake the journey. By no means is that a comprehensive answer to the question, but they might be a couple of, key points that I've seen used to good effect many, many times.
Okay. Klemen, Matthias, do you have anything to add to that?
Yeah, sure. I can add something. So I think probably we all have realized, any type of learnings have to start with the data. And still, I think nowadays it can, be a problem that the data is not actually prepared in such a way to allow for an analytics or a machine learning workflow. And I think that's something, a lot of companies still have to implement and prepare for, to realize they need to do the proper data engineering beforehand before they can extract the value from the data. So I think that one is still a bottleneck. Apart from that, I believe there's always room for automation. For example, let's say you have a sequencer. Do you need some people from a genomics core to pre-analyze the data for you, or isn't that a process, for example, that can be automated, that the data from the sequencer triggers a workflow that automatically generates the result, and then whatever sends an email to the respective person that's supposed to look into the data? Or shouldn't there be, let's say, some sort of dashboard where you can just see, okay, these are the samples that have came in, what is the status of the analysis, what's been done, what's still to do? I think there's still a lot of potential there to automate and let's say take possibility for human error out of the equation.
Yeah, I kind of like to also address the discussion, the QA, like what's the ROI, right? The ROI, ultimately, when you're implementing software, the ROI should be, or fundamentally should be the in one way or another, the let's say the driving factor. So on one hand, we have shown, so we did an analysis with both academic and industry clients on their time savings and how much, how long you need to implement and how much effort do you need to put into onboarding everybody and how much added value there is. We were able to see that on average, people were saving one day of work per week. So this is and primarily due to reducing in reporting. So once you have the data organized well, extracting the data becomes really trivial. So building a report it takes just a few clicks. A report for your lab meeting, for your founder, for writing a grant proposal, or writing, or I don't know, a scientific paper. So this is something that we've seen is a huge driver. As Timothy in the chat was writing, pharma has here very clear ROI drivers. The data is very valuable, But academia, in academia, your main driver is time, and you can save time with software tools. That's the purpose of software tools. I understand that people, and this is kind of my second point to this question, how to build a data-centric lab. You have to be, if people generate data, it's kind of like, you need to build a people-centric lab. So people need to be aware why having a data-centric lab is important. They need to understand the ROIs. They need to understand how this impacts. They need to be involved into making decisions how to enable data-centric labs. So it's really, if machines are making all the data, you just need integrations. If people are generating your data, you need to you need to have a way to talk to them and include them in the process of digitalization.
Mm-hmm. Thank you. We saw that earlier based on the poll that a lot of people are kind of in the beginning process, just learning or taking the first step. If you have like one tip, like this is true to all the presenters, one tip that you can just give to people in the lab, and I know that we're, don't have a lot of time. What would you say? What would you tell them the next step should be, or the first, what's the focus should be? Alan, go ahead.
Yeah, again, this topic could take an hour.
Yes.
In general terms, where I've seen this sort of done really successfully, and there's lots of different paths to success here, but maybe one common characteristic is, start with the desired endpoint in mind to the extent you can. So I think, as we start to assemble the data and make it available, we will end up subsequently doing things with it we could never have dreamt of. But to the extent you can, try and define the desired endpoint and then build the foundation that's going to be required to fulfill that desired endpoint. And then look for some early wins, whether that's a particular workflow that is ripe for automation that might yield good return on investments in terms of time saving, as the other speakers have spoken about. So that would be my sort of very, very short answer. To the extent you can, define the desired endpoint, focus on putting the foundations in place, and then look for early wins, because I think momentum begets momentum. And if you can start to demonstrate return on investments, typically what I see is other scientists, other labs, other departments, divisions then say, geez, it'd be great if we could do that also. So that might be my super brief answer to the question.
Yeah. Klemen?
Yeah, if I can just add to this, taking it basically step by step. You need to first understand what you want and where the bottlenecks are, and kind of prioritize. Some things have simple solutions and some have very difficult solutions. But once you have at least some idea, take it step. Try to break it down to individual steps. Mm-hmm. It's really important to have these early wins. That it's not too much at the same time. A lot of time we see people were 200 people, everything was paper-based. Now everything goes paperless overnight. It's going to be very, very difficult, and if it fails, it's going to take a long time to restart that project. So really taking it step by step. What's the biggest pain point, and then you resolve that pain point with software, and now people start to have trust into the solutions that you're bringing in. Oh yeah, now I don't have to do all this manually. Just press one button and it gets done. So right. Yeah, basically what Alan said.
Okay, Matthias?
Yeah, so interestingly, interestingly, I had the same ideas in mind. So one thing I always also recommend to my clients is to think about the questions they would actually like to answer using, digital systems, rather than saying, let's say, I want to use machine learning, right? I mean, you need to know what the questions you want to answer to build a system that can give an answer. If you build, let's say, the wrong system that cannot give you those answers, it may be a lot of work, but probably not what you want. So really focus on having something that's customly built, decide on what you really need. Start small, start with the biggest pain points and build up from that. And I think that's also one point about stakeholders, of course, because historically IT is always seen as a cost point. So there's a bit of hindrance there that people don't like to invest in it. So you really need to find something that can provide that that value, that gain, that return on investment. And it was also mentioned in the Q&A. So I think to focus on a small study and do a pilot and show that it's really working and adding value, it's essential for those kinds of projects.
I want to wrap up this with one last question. We are talking about this, all these different machines and components that integrate. Does this look different between like a bigger lab versus a smaller lab? Like, will they be looking for different kind of system or solutions, or do you think there are tools that can help with that, regardless of the size of the lab? I don't know if that's a question that anyone might be interested in answering.
I can maybe start. I think it's yes, it's size is one of the factors that definitely should influence the decisions that you make, but also ultimately it's not the only factor. Like really depends what your ROI is, what your end game is, why are you generating data, how do you monetize the data, be it you want to sell the company or you want to write a scientific paper, what kind of data you want to base this on, and then finding a path how to get to this data, because these projects can get very complex very quickly.
Yeah, I might add, interestingly, I tend not to think around this type of question in terms of size of the lab, but more in terms of, what is the use case? What is the scientist, the lab trying to achieve? And it might be that a smaller lab might have fewer instruments or fewer scientists, but could still have very, sort of complex workflows, which could benefit hugely from what we've been discussing today, which is, automating the workflow, getting more advanced analytics. So maybe that's the way I would think about it in terms of, what is the end use case? What is the return investment on that use case? And therefore, what is the most appropriate sort of tool set to solve for that?
So, and yeah, to finish up from my point of view, I think the main question is that of scalability, efficiency. So of course, the larger the lab, the more data you will have, the more processing you will need to do. And of course, that begs the question, which systems are you building up? So obviously, if you use cloud solutions for that, where you can basically scale in principle infinitely, and you build that system up with the appropriate, let's say, fallbacks, then you can also build a solution that's really future proof. Even if you, let's say, have a smaller lab, you can easily scale up later on.
Perfect. With that, I think we're coming to the end of the hour. Well, we kind of went over the hour a little bit. So I would like to kind of wrap it up here. And I would like to thank everyone who are here with us for the sessions. Make sure that if you have any questions, do let us know after the session. Feel free to contact us. We will send a video as well as some of the response. We'll kind of summarize it and make sure to share with all the attendees. Thank you all the presenters for being here and sharing your knowledge about this topic. And thank you everyone for participating. Have a great day.
Thanks, folks. Have a good day.
Bye.
Thank you so much.
Bye.
Bye-bye.